old are you, Dad? How old are you?
How old am I?
Yeah.
I mean, I'm old, huh?
How old are you?
I don't know. But should we say welcome to class?
Yeah.
Say welcome to class.
Let's go into class.
I'm Michael Allison. This is my son, Aiden. We call him Big Mac. He's going to be playing on the floor over here next to me doing Legos while we talk about mechanical, electrical, plumbing, or MEP, and some other things in this course. I'm glad to be here. You want to go play now?
Yeah.
Okay. I'm really excited to be a part of presenting on these topics, and I say we get right into it. So today, and to start off the course, it's going to be covering all kinds of stuff related to mechanical, electrical, plumbing, the design, the components, the systems. But before we even start there, I want to get into, from a general contractor standpoint, what I think is maybe the most important, I don't know, but it's definitely up there as far as how important it is. And we're talking about coordination of trades, coordination of sequence. And so got a little bit of a PowerPoint here, and then I'm going to jump right into the drawing. So I like to over communicate a bit. So we're talking MEP, it's a term you're going to hear all the time, mechanical, electrical, plumbing. It would also include things like fire protection, controls, pretty much the dynamic systems in a building or a project. So we're going to use the term MEP for that. And then at certain times I'm going to make sure we don't use that term. But for now, we'll just do that. So the basic topic of what we're talking about of coordination is the physical space, the transition, and the interface. And what we're looking at in this photo is this is some piping at a central utility plant. And you think of the physical space that all this stuff takes up, not just the component or the pipe or the system, but also the physical space of the hangers or the physical space in order to rig it and get it in the space. For some reason we've got a broom over here holding something up. Who knows what that is? Physical space of equipment. Physical space is what we're talking about coordinating. And something else that's really important as a principle to try and coordinate is a transition between, and this is true not just for mechanical, electrical, plumbing, but for all kinds of construction. So you think of the transition as this pipe goes out of this building and down the utility tunnel. There's a transition as it comes out of the ground into the building. There's all kinds of transitions to think through as the different mechanical, electrical, plumbing trades perform their work. And so something else that I think is really important to coordinate is the interface between the two. So we have an interface here in this photo of these hangers as they interface with the structure. And the idea of interface is really is something touches something else or comes in contact with, or it needs the electrical interface or the working fluid interface. Anyways, we'll get into all those details, but I want to present those ideas of just like the physical space being something to coordinating the transitions, and I'll give you a real live example. So what I'm not going to talk too much about in this particular lecture is the MEP VDC coordination. It used to be called BIM, now they call it Virtual Design and Construction. Who knows what they'll end up talking about, calling it later, but it is our industry. Coordination is such a big deal that some projects actually require full coordination to be done between the trades, and a virtual model is created with highly detailed drawings of each of those trades, their work, and then looking for some how it's all going to coordinate in the physical space, the transitions, the interface. Not so much the interface, but coordinating the physical space. We'll talk interface more. So I'll show you that today, but this lecture is not about that. I'm talking about basic coordination, and so the examples I'm going to give are going to be more basic. But I will show you that, and I'm going to use that model. So the basic, I want to talk about coordination and then construction sequence as well. So if you think of a construction sequence and a very generic construction sequence where you got to have a hole in the ground before you can put a footing. You got to have a footing before you can put a wall in. You need to have a slab, a concrete slab before you can go do your all your framing and on the basement going up, and you got to have foundation wall. Anyway, talking about construction sequence. So for mechanical, electrical, plumbing, as it relates to that, the underground work is usually deepest to shallow. I'm going to pull that up in a second and we'll show you that. Deepest to shallow, meaning the deepest things typically are installed first. It's just a rule of thumb. It can have other constraints, but I'm just talking about generalities. Now, in a wall, the drain waste vent is usually the first thing, and I'll show you here in a picture of that. And then above ceiling is usually the highest to lowest, meaning you work from the top down in a ceiling space. And let's look at the drain waste vent in a wall, because we're going to use the example of the plumbing underground here in a second, and talk about that relative to sequence and coordination. So I think this is a good photo to illustrate the importance of why drain waste vent is usually first. So because the drain waste vent is usually a rigid pipe of some type, whether it's, I think this is cast iron, or it could be, I don't know, there's ABS. We're going to get into the types of pipe. We'll get into all that stuff. But really, I just want to show that it takes up a physical space, and it has to be in a certain location for it to function correctly, meaning for it to do its job, right? So you can't have, you can't just willy-nilly put in the electrical on the wall and then expect all the drain waste vent to work. Not that there would necessarily be a lot of electrical in this wall, because this is obviously, well, no, that's some sort of carrier for toilet or something, looks like to me. Anyway, but there could be some electrical on the wall, but it would definitely go later. And I think this is a good example because this is showing that the pipe, the racks, all that stuff kind of has to go first. And as we talk about above ceiling and that sequence, you can see the fire suppression line, this fire sprinkler line, it's above this ductwork. Look how close that is to the beam. And so it would be pretty hard for the fire suppression contractor to get his pipe in after this ductwork is in. So generally, again, the rule of thumb is to work from the top down when we're talking about construction sequence above the ceiling. And you can see in this example, they've got some electrical cable there and some conduit here and some other things, and it's down lower. But it looks like to me this cable tray, even though they put the hangers in, maybe it's for ductwork, I don't know, but I know this building had a lot of cable tray too. Maybe it's ductwork hanger, I don't know. Maybe it's pipe hanger, but anyways, it's lower, and so it has not been installed other than the hanger. The hanger has come down, and that's fine, but the actual component or pipe or whatever system is on this hanger, that is not installed yet because the things above it need to go first, need to be allowed to go in first. There's some debate, and folks feel differently about whether you should try and block out holes in stud walls for ductwork to pass or not, or whether you should just let the framing go up. But I think that's something important to think about as you're talking about construction sequence, construction coordination. I've seen folks even decide that they're going to put the ductwork in and then frame around the ductwork, which I think is a good, it has its merits. I like the sequence, it's good. That doesn't always work, but it is a good strategy sometimes. But you do need to think about, can people physically get into the space? Can they do their job? Can it be done in a workmanlike manner? Can it be done safely? We'll be talking about safety even more and more about all those things have to be coordinated, and they relate to the construction sequence. There's another example of above ceiling, and you can see that the piping here has to have been gone before this ductwork. You can see the fire suppression back there. I'm thinking it is. It's hard to tell on that line. Maybe that's a drain. Maybe it's gas. I don't know. Can't tell from this photo. Maybe the folks that are really, really good at MEP can pick that out right like that, but I need to have the drawings in front of me. I work more as a general contractor than in specialty trades like this. So I feel like my knowledge is not necessarily about absolute finite details, but it's fairly broad about the entire topic, and that's what I'm hoping to present. But I think it's good. You can see the hangers. The hangers definitely needed to get put in first. They're up high. Don't necessarily finish what's on the hanger, but that needed to go in first. There's some things in the way. You can get straps put in first. Think about the things that are down below. Maybe other things that need to be hung, like the grid ceiling or something in a hospital. You'd have an overhead unit or something like that hanging from the ceiling, and those things being installed first before you get into other. All right, now I put the construction sequence of underground, talking about it being deepest to most to shallow, and I want to give a couple examples of that right now. And a good example of both construction sequence and coordination. So let's I'm going to bring up some drawings here. I'm going to use Bluebeam. I like Bluebeam a lot. But this is kind of the phase of construction we're talking about being in. As we're going down, we're going to put footings in the ground. We're going to have piping. And this is just a cool photo of one of the jobs that had a limited part in, and a lot of good team there. I think that's a great photo. But that's kind of the phase. This isn't the actual job. So let's come back to this PowerPoint here in a second. Okay, now I'm going to talk about this from, I'm going to try and describe the entire scope of work that's going on at the same time, rather than focus just on plumbing or focus just on electrical or mechanical. I want to talk about it in context of what's going on the project. So the photo you just saw, imagine people excavating, going down. There's a cool part of this project. I'll show you that here in a second. That's pretty unique. But I want to give a context of what's going on. So we're in the mode of doing footing, foundation, underground plumbing, underground electrical. Hold on just a second. Yes, son. All right, we've got the phase of construction. We're going down, right? We're talking footing, foundation, substructure type stuff. All right, let's look at this structural drawing and just give you an idea of what it is that we're looking at. So there is the outline of the building. What you're seeing is footings for columns. You're seeing the foundation wall, and we'll zoom in here a little bit more and give you a better idea. So this is a column C5, C5. There's an H style type column. Here's a footing F4. So the footing is dashed. It's below ground right here, right? So the HSS is talking about tube steel. These are all call outs. I'm assuming you guys all know what this is, but I just do want to over communicate. And these footings are what we're talking about is the main scope. We've got plumbing as well going on. Kind of give you a feel for this over here is a trench drain, and they've got some concrete over there. We're not getting to get into the details of that. Let's look at the plumbing underground. And it's only a single-story building, so it's fairly simple. It's not that many square feet. And we were looking at previously footings along this wall, and you can see where those columns are, and into those there were footings, right? Foundation wall, foundation wall. If we come over here on this side, you can see that they've got a 5-inch pipe from above, and this is the secondary, I would just say roof drain, but they have actual term for it over here. Roof drain pipe, and they're calling it a rainwater conductor terminal, whatever. Rainwater pipe. So this is they've got basically a roof drain pipe and an overflow roof drain pipe, secondary roof drain. And you can see that they've got those here, 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 and they're on every column line almost. So if we looked at this, so the secondary roof drain is coming from here, and it's making its way over to near this column and going down. And then as it goes out, this one's note number 4. So this is the secondary, the S, and this is going to be the primary, even though it's called our rainwater collection or something like that. It's a roof drain pipe, and this would be the primary and secondary roof drain. The basic idea behind a primary and secondary roof drain, we got a roof line like this, and we're now looking at a cut section through the building, okay? And so near the point where the roof comes together, or the trough, you're going to have a roof drain to collect all that water, right? And so then there's going to be another roof drain. Whoop, didn't do the control key right. And they're not at the same height typically. They can either be offset vertically, or there can be a ring on top of this one. So we're just going to say that one is higher than the other. And the idea is, that during a normal rain event, water on the roof as it comes down collects in the lower roof drain, or the primary roof drain. We'll put that one there. And they're only offset by 1.5 inches sometimes. They're not very much. You don't need to be offset very much. But if a large pool of water started to pool up here, and it's amazing, you get into a large downpour, how much water can actually be on a roof. The amount of water that gets collected around this roof drain exceeds the amount that this pipe can take, starts to pool up, and so that it does not put a load on the roof. They have this secondary roof drain there, and it starts collecting water as well. And the difference is, so we've got the roof drain here, we've got the secondary on this side, we've got the primary over here. So this roof drain's lower, it'd be this one, and this one be higher. And it actually looks like to me I probably drew this incorrectly. The roof probably goes like this on this building. Even though it's still a low slope roof with a PVC or a my goodness, TPO roof, it's still low sloped, and it's probably towards the edge. Let's see. Yeah, this would be the ridge line, and it's sloping towards the edge of the building, just like that. But anyways, the point being, the primary, which is this one, it's going to the civil. What what in the civil? Well, it's going to the storm drain. So the water that would normally, during a normal rain event, going to come down, hit this roof drain, and go into the storm drain. If they get so much water on the roof from an rain event, that it's overflowing this one, it starts to get bigger, starts to fill up the roof space over here. It'll hit the secondary roof drain, and what does it do? Note number 4. Well, note number 4. It's just going to hit a splash block. So it's just going to come about, I don't know, 1.5 feet, 2 feet, 3 feet above the ground, and it's going to come out of this pipe and hit a splash block right here. Usually concrete splash block is no big deal. But the difference in elevation is significant, right? So this one's above the ground, and this one is below the ground. And how deep is this? How deep is this this pipe? Well, this is a single-story building, no basement, and so I think the footings on this are probably 2 feet below grade. I don't know. Maybe it's on the foundation drawings. I didn't notice. But so this is down below. Well, what is it traveling through? As we're talking about coordination and physical space and construction sequence, this is a good example. Well, what is here? Let's look at what this might look like. And all right, so let's pretend like this cut section in this drawing is what we're looking at. So, and we're going to draw a little bit on this thing. Whoops. I'll get better at this, I promise. Okay, we're going to say that the storm drain is over here, which I think is fairly accurate with what that example we had was. And then we had a roof drain coming down, and let's say it goes out the wall right there. That's the secondary. And then we had a primary coming out of the roof, coming down, and it was saying that it was going to go about 5 feet outside the building line. And so that guy right there, let's just give it a different color so we can tell. All right, we've got the secondary roof drain coming out, hitting a splash block. We've got the primary coming down and going in this space. But what was there? What was in this space? So let's go back to the structural. And here's the foundation line we're talking about. Let's make sure, let's be thorough. We're talking about grid line A's. And we'll go over to the plumbing underground. And sure enough, we were talking about the same grid lines. Okay, we already knew that, but I was just trying to show that to be thorough. Make sure we're in the same spot. And we've got a whole series of them, right? We've got this one on grid line 14, grid line 13, grid line 11 and 8, 6. All of those have primary and secondary roof drains. And we see 14, all of them have the foundation F4 spot footings. All of them have an H column, the I-beam column. And so we've got roof drains coming down, taking up, at least one of them is taking up the space, is going to be in conflict with the space of this footing, and maybe even this, the fur out in this location, right? The framing. So we've got construction sequence to think through. What are we going to put? What's the lowest? Is the pipe the lowest? We'll have a little surprise for you. That's not actually what was below the footing. The footing is not the lowest thing. The dirt is the lowest thing, and the dirt on this project, it was pretty dang cool project. Little building, but pretty expensive dirt work on that. And I believe there was 5 of them per, I think, per footing. Could be wrong. But there were geopiers. geopiers underneath the footing. So if we had a roof drain pipe coming right down through here and then going below the footing to the civil, it's not only going through a concrete footing that is kind of probably not too good for the structural engineer to think about, and this is an H column, so most likely this is not just a gravity column. This is in a Salt Lake Valley, and so this is most likely part of the frame maintaining lateral loads, right? So this is part of the seismic requirements of the building, or the design, seismic design of the building, to have this kind of column and not just a tube steel, right? There's a tube steel right there. This is H, so this is probably a brace frame. I didn't look it up, but this whole frame right here is going to be taking care of lateral loads, which also means the rebar in this footing is going to be more, which means there's also going to be bigger bolts for this column. All that equates to not enough room for this pipe to get into this below the footing and out. So I do want to talk about what I like talking about, the entire assembly, the entire system. Let's look at what these. I found this thing on YouTube, just a good example of what a geopier is. So they take a bunch of rock, they go put it in a hole, and it's pretty sweet, and they go vibrate it down, and it creates these mushroom looking things, and it improves the bearing capacity of the soil. So this was a project near Jordan River, if you know where that is, and it was river bottom type sediments. And this is actually what we had right here, where they vibrate this piece on a track hoe down, and they fill it up with gravel and then go and vibrate it. That's exactly what we had on our site, was something like this, and to improve the soil. So think about a pipe coming down. Well, stop, go back. Who knows if this is actually legal to do on YouTube? I don't know. Well, that wasn't where I wanted. I wanted it right there. Okay, we have a footing. The footing's actually down here. But think about a pipe going down through this stuff. Would the soils engineer like it? Would the structural engineer like that? Do we have a design conflict? Sure, we do. I think that it's worth. There's multiple designs involved here that matter, and this should turn into a request for information to the designer, and we should be asking them what they want us to do with this coordination conflict. If it wasn't this complicated, and I was the site supervisor on site, I might just say, well, we'll just coordinate it on site. We'll make sure that we bring this pipe down into a chase, and then as it gets down below the floor slab, we have 2 or 3 feet, we'll just move it over here, and we'll get it to come out this over here. And I might just coordinate that on site. But because there are so many of them, and there are multiple trades involved, and I also think that because it could potentially cost one or more of the trades money, I think it's worthwhile getting the designers involved, letting the designers try and take care of this specific coordination issue, and go ahead and do it that way. So what would I do if I was to do an RFI? Obviously, there's different systems to use. This isn't a class about like writing an RFI, but again, I like putting the whole thing in context. So let's do that. We're going to write an RFI that says, RFI stands for request for information. We're formally requesting information. So we know that it happens over on grid line L and grid line A, and I didn't see it anywhere else. And so our request for information, I like them when the title is simple but descriptive. So we're going to say roof drain piping conflict with foundation and geopier possibility, and that's the title. We're going to reference this sheet name right here, P202. We're going to reference this sheet here, which is S1.1, and it would say something like on S1.1 and what was the plumbing drawing again? Sorry, P2.2. There appears to be a conflict along grid line A and grid line L for the roof drain piping as it travels down from the roof to the below the slab on grade and into the footing and geopier area before traveling to the civil storm drain. Please review and clarify designer's intent and provide direction. Excuse me. You don't have to be a super wordsmith or anything like that, as long as we're getting the drawings, the grid lines, your question. That's all they really need. It would be worthwhile, though, to go ahead and take up a couple of these drawings right here and do something like this, though. Whammo. Oh, it didn't pop up like I'd want it. I just want it to be like super like, oh, there you go. Okay, cool. So that's what we did. We actually grabbed Bluebeam, overlaid the two drawings, and what you can see now is the green is the foundation, the red is the pipe, is the plumbing, and we've got the conflict right there. And we gave them this drawing so that they could see easily what was going on both in the plumbing and below. Plumbing and the foundation. And we attach this to the RFI. Give them that information. Now let's switch gears and look over here. Let's go look at plumbing. We've got the men's and women's restroom right here on this drawing. We've got some smaller restrooms over here on this. But let's go look at what's going on at grid 11, 8 to 11, and grid lines E to G, roughly. E to G 0.5. And yeah, 8 to 12 will work. Okay, here's 8 to 12. And E to G 0.5. And what do we got right there? We got some footings. Again, and H columns. And we've got, what is under there? Geopiers. So let's go look at that in the overlay as well. And sure enough, all the plumbing is going right over that footing right there. And so it might be worthwhile sending the RFI as well about this area to have the designers coordinate and look at this as well. Most likely they're just going to say move this this drain sewer line, excuse me, the sanitary sewer line, and they're probably going to have it move over here in this space to get it out of this footing. But going back to the idea, right? So we're talking about construction sequence, construction coordination, and I was hoping that this would be a good example to be able to say, all right, we've got to physically, as we think about mechanical, electrical, plumbing. I think the course that I got in college really focused a lot on the components and tried to teach me the components of each of those things, which is great. And I'm going to do that because I think it's worthwhile. But I felt like when I got into management, that this was the number one thing that I needed to be doing as a general contractor, was making sure that they were coordinated. And I want to talk about coordination just a little bit too. So the general contractor, in my opinion, you can get some, obviously regionally it's going to be different, and I'm going to try and explain that regional differences. So different parts of the country are more litigious than others, right? And so if we get into a litigious area, you see some of the general contractors with this kind of thing would what I would call be laissez-faire, hands off. And the trades would have to come forward with this conflict, and then the general contractor would never do what I said. They would never like, oh, hey, I think we can just reroute this over there. They would immediately put it in the court of the designer and let the designer give them an example, respond, and however much time that took, that would get documented, and they would follow the exact letter of the contract to be able to request time for whatever delay it was. And so, in my opinion, that's a not a very good general contractor practice. I don't like it. I understand why it happens that way. I understand the litigious nature, and if I was out there and I made a decision like this and it ended up not being right, and then I took the liability on myself and I owed the cost, I get all that. But I think there's a happy balance to be made, and I prefer not to be on working for the highly litigious contractors and on those projects. They're not very fun. I know that they can happen. I know the larger projects get that way. But it's the way it is, right? So understanding that that's part of the pendulum. On the other side of the pendulum is people just not caring, I guess, not really thinking it's part of their job just because they don't want to, or maybe they don't have the I don't know. Anyway, there's both sides of reasons of not doing it. One, because they don't want to do litigious things, or maybe they just don't have the experience, or maybe they're lazy. But in my opinion, it is the general contractor's job to try and get the trades to coordinate. And we have something called a subcontractor coordination meeting. So that is something that should be talked about. We're working in this area. What do you guys see that could be a coordination issue for you in this area? And a good general contractor, a good site supervisor should be able to see pretty quickly, okay, we've got pipe, foundation. Let's just see what's there. And flipping through a few drawings, you should be able to find this pretty quick. And there's a coordination issue. So what happens if we don't coordinate this stuff? What if we don't think through the construction sequence? We don't put so just thinking through that. Say we went crazy with the geopiers. We got the foundation going. And then the site supervisor decides, oh, I need a plumber here, and the plumber finally gets here and says, oh, well, wait. And then what if what if this guy is or lady is a good pusher, and he got the civil in first, because that was the first package that came out from the designers, and he's got this civil line already run, the storm drain, and he's got it stubbed out right here where it's supposed to go, and right here where it's supposed to go. And that's already in, and the foundations are already in, and now we've got a problem where the roof drain needs to be coming down and connecting to that pipe somehow. The point being, it's going to cost money. It's going to cause a delay to not do coordination to some extent. And so this is very basic coordination. What do we need to do? I want to give another quick example of this, which has even less information in it. And now we're talking about, we'll just do this one. Whoa. Okay, we'll do that. Okay, now we're looking at a multifamily condos or apartments. It's simple, right? And there is no plumbing information. All that's there is this sink. That tells you there's hot water, cold water, and drain lines there. There's no pipe running there. There's no drainways vent showing. It just, that's what they give you, and plumbing contractors are gonna have to put it in per code. So that right there, knowing and kind of what I already know and you don't know from you don't have the experience on this job, but I apologize. The way they did this was the kind of like line that up. This is the main floor, that's the floor above it, and so this actually sits on top of that. And so there, if you're looking at it from the side, this area right here pops out. And so what happens to this? Well, if the plumbing and stuff is in the floor cavity, then you got to find a way to make sure that it is heated in our climate, right? So you can't have a water pipe in a cold wall without it being protected, or I can't remember the exact term, but it can't be in a cold wall without having heat on it. So some way to heat it. So how's this piping going to get down? Well, it can't go down. It's got to come towards this wall and get in this wall. Well, how are you going to get piping to go? Okay, well, think about, okay, there's glass here. There's a big window. So we've got this little piece right here, that little piece to get water, to get... I'm trying to teach a class. Give me a minute, okay? Okay, thanks. All right, thanks for your patience. I'll figure out a place in the house so I can do this without having my kids get after me. But I love them to death, so and I'm passionate about this too, so it matters to me. Excuse me. Think about the physical space that it takes for the water line and more specifically, let's talk about the sanitary sewer line or drain waste vent line, to be more clear. How is it going to get from here down below ground and out into the sewer? Well, it can't go above through the window, and it's got to go in this space. So let's just look at the structure. Let's see. And what did you know? There's an HSS 4x4. That means tube steel. There's a tube steel right here and here. And what does that call for? That is a Simpson shear wall 21 by 7.4. So I'm pretty sure I know what a Simpson shear wall is, but let's go Google it. SSW, what was it? SSW 21. This is part of the class because this is what I do a lot. And Simpson strong wall, not a Simpson shear wall. Okay, I got it wrong. It is a Simpson strong wall. What is that? Well, it's definitely part of the lateral support of the wall. And if we got into the details, which I already know what it is, we're not going to put a pipe through that. Okay, so back to the question. How are we going to get plumbing through here into this wall, which is actually down, the wall below it is, see this is out, if you're looking up and you're standing, you'd be right here below it. How are you going to get that out? We're talking about coordination, construction sequence, so on and so forth. So let's just say we did no coordination. Our site supervisor doesn't really get anybody talking to each other. Plumber doesn't take the initiative to go talk to anybody about where this is going. He's not really motivated to do that. And he just decides to stub up some plumbing right here or right here and decides, well, I'm just going to rely on it being right there. Well, what happens when they go try and do the foundation? Well, now there's Simpson shear wall, anchor bolts down in the concrete. There's a conflict right there. Who pays for that? Does it delay the job? I don't think that in this kind of a case we could really pin it on the designer, because this is a super cheap design in my opinion, meaning like I don't mean to say that it's done poorly, it's done well. It's just that not a lot of expense has been paid on this design. So obviously the designer was not paid to try and coordinate. Obviously they're not paying for BIM models. Obviously they're not doing that level of coordination. And so it's up to the contractor to do it, and it's up to the trades to do it. And so Sure, we could write the RFI, but if it's not coordinated well, it's going to cause a delay. It's going to cost money. It's going to make people unhappy. There's also the whole culture of the job site that gets affected when stuff like this happens. Trades start losing money, having to rework things at their own cost. It gets really uncomfortable. There's a lot of animosity going on the job site. It's no fun. It's in our best benefit to try and coordinate and think through the construction sequence. All right, let's jump back into my PowerPoint and see if I missed anything. And I talked about this a little bit, that we might have to get the designer involved. It's a more significant issue. Contractor is not the designer. That's something I didn't say, but sort of mentioned it and talked about the litigious nature of things. If I went out there as a site supervisor and decided I'm going to move the pipe over here or I'm going to move the footing, that's not my job to design it. So that's one of the reasons I would recommend an RFI. Oh, I didn't talk about this. The drawings need to change in that case, right? So we have a pipe there. Are we going to end up just redlining it? Maybe. Are we just going to there needs to be a final set of drawings at the end of the job showing where everything is, and if we get it in the design team's hand early, they can make the design changes and draw it the way it needs to go, and we don't have to try and do red lines later. I talked about writing an RFI a little bit. Yeah, I didn't use all that. This is good notes. Page names, grid lines, I talked about that. Use room numbers, locate the issue. And I didn't do this, but add a suggested path forward. And this is, I think, the whoever you work for is a prerogative, and work for different folks. And so some people feel like that's a good thing, suggest how to fix it. Some people do not like that, feel like it's too much of, it's not not the job of the contractor to do that, and so they won't do that. But I do. I usually have what I think is a good path forward, and I usually write down what I think is a suggested path forward. All right. Oh, yeah. Impacts of poor coordination. We talked about this. Schedule delay, rework, last minute decisions. We're talking about costs go up. This is something I've come across more and more, that the designers just don't have any sympathy, and the designers are working with the client, and they're looking out for the client's interest as well. So if, say we didn't coordinate very well, obviously didn't put any effort into a coordination effort, the designer's not going to go to bat for us with the client saying, no, they did do a good job coordinating, and this is an additional cost that we need to pick up that we'd recommend the ownership group pick up. Or if you don't do coordination or any effort and you're not doing it, never going to have the designers on your side in any of those meetings. Nah. You can see that I didn't want to use this PowerPoint too much, so add a slide title. Okay, what's that about? I'll get better at this. Okay, I want to show you just a couple things. We talked a little bit about soils conditions, right? And this is this right here is a soils report. Actually, is a supplement to the soils report based off of the site visit. And it says a portion near the middle of the proposed building consists of bedrock, which extends approximately 5 to 6 feet above the finished floor elevation. Oh, well, in the original soils report, it says that there isn't any bedrock down there. Well, apparently there's bedrock down there because they just saw it and they excavated down to it. So as you think going down and substructure and plumbing and what to coordinate with, it is not just the things that are drawn on the drawings. It's the earth, it's the groundwater, and it's the soil types. So, and you think through some of the other things you have to think through is the safety of what you're going to be doing and the logistics of it. So let's just say, we'll just pull up, just do a little drafting here for a second. Oh, you know, I should do it on that plumbing, on this foundation one. That would work. Okay, remember there's somewhere over here, there's a civil line that's not shown, and there's plumbing right here. And if we're looking at this drawing, remember there's a bunch of plumbing right here. So normally that plumbing line's not very deep, but it could be. Let's say that it is. So if we're talking about safety and people are working in the same spot, where do their spoil piles go? How deep is their foundation? Can they or how deep is their excavation? Can they work in it safely? Are they creating a hazard for other people that are also working in that area? Are the spoil piles going somewhere that are, if say the plumbing line went right here and they're digging an excavation that's going to go right through there, are they dumping the dirt right on top of this? And so are we ended up, let's just imagine for a second you have a big spoil pile right here, and they're excavating this and they're dropping their spoils right over the top of your footings and foundation that just got poured. Well, or what if they're not poured yet and you need to be working concurrently together and you got a bunch of spoils piles there? So we're talking about coordination construction sequence, and it's not just the components that work, but thinking through that logistical thing as well, and super important. Hope that whole concept of what can happen if you're not coordinating gets in your brain, because I wanted to start with it. I think it's the most important thing. I hope this was a good primer for what we're going to do for the rest of the year as we look at these individual components and systems for both mechanical, electrical, plumbing, fire protection. We're going to keep coming back to this concept of coordination. I want to end as a flyby. We're going to do just a little bit of Navis here. Ooh, and this is what we weren't talking about, but we'll get into later. This is full-blown, paid for by the client coordination. Look at that. They got the roof drains and the overflow right there. They got their roof drains. Whoops, let's go down. They've got their roof drains right there, the roof drain piping. Try and get in that space. And we're talking about working high to low. Look at that, that's fire sprinkler line for sure. That's the only thing that drops down like that. It could be fire sprink. They've even got the hangers detailed. They've got piping. This looks like it's the highest to me, so this was probably the first thing that went in. My voice is getting, I need some more water. We'll get into more details. You'll be able to see more of this stuff. We'll get into what all these components are. So thanks for joining with me.